Hey everybody, you're working on your review for 2.5 to 2.6, and the first one has a lot of piecewise functions, and here's your graph, and we want to know if f of negative 3 exists. So what that means is it defined for x equal negative 3? And at negative 3, yes, it is defined. You can also go to the piecewise function, which falls in the interval. Negative 3 is in between there, and so you could say negative 3 plus 5 and you get 2. So yes, it is defined there. The next one says, does the limit exist? So what they're asking is, does it approach the same number from the left and right? And yes, it does. What you have to watch out for is sometimes they have yes first and sometimes they have yes second. Now the next one says, does the limit equal the function at that value? And yes, they're the same. Both are 2. And is it continuous at negative 3? Yes, there's not a hole. Okay, so that's the first one. The next one says, at what points is the function continuous? So on this one, you could try to factor the denominator and see if it cancels the numerator. Sometimes it does, sometimes it does not. So in this case, we would have y equal to x plus 4 over x plus 4 times, let's see, you'd have to have x here, you'd have to have a 6 here. Since you have a negative 10, that's not going to cancel. Since instead you would have to have x minus 4 times x minus 6. So if you have your x minus 4, x minus 6, you get x squared. Negative 6x minus 4x is negative 10x, and then plus 24. So it is worth trying because, you know, sometimes we're able to cancel it out, but here it does not. So this part. Now what we're going to do is graph it, and you can either graph this one or this one. By the way, if they match, then you know you factored right. So in this case, we want x plus 4 over x squared minus 10x plus 24. Okay, there's the graph. You may want to do zoom fit because we're not really clear about what's happening between here. So do menu 4A. So menu 4A is zoom fit. And getting back to checking, did it factor right? You could say x plus 4 divided by parentheses. You do need a double parentheses here, and you're going to have an x minus 4 times x minus 6. And since it exactly traced it, we know we factored it right. And so the question is, describe the set of x values where it's continuous using interval notation. So it's continuous all the way to right there. So it looks like you have a vertical asymptote at 4 and at 6. Vertical asymptote x equals 4 and x equals 6. Again, the reason to factor it is you know that that's going to be right really easily. You could also do Control T to look at your table, and at 4 it's undefined, and at 6 it's undefined. So what that means is we're going from negative infinity to 4, parentheses, union 4 to 6, union 6 to infinity. So all of these are parentheses. So here's what I had written earlier. Vertical asymptote at x equals 4 and x equals 6. And basically this and this indicates your spots for your VA. And so you're going to have 3 parts. The next one says determine the points at which it's continuous. So since these have a common factor, we can factor that out. Factor out a 7 in this case and get x plus 2. What that means is you're going to have -2, 0 as a point, and then it's going to go to the right. So basically, go to -2, and then it's going to go up like that. And you can do this from the graph. Square root of 7x plus 14. So at -2, it starts going up. So just as a quick side note, if you took off the 7, it's not going to go up as high. It's going to be like that. So you basically know that when you factor it out, that's going to help you get your x-intercept. And this one includes -2. Square root functions include the endpoint, as opposed to rational functions. So again, when we had our rational function up here, we had parentheses throughout. I'm just going to say parens, and this one we have a bracket. Okay, so then for our next one, we have a piecewise function, and it says at what points is the following function continuous. So on this one, I'm going to try to graph this part through the calculator. Graph this part in the calculator. It has both a +2 and a -2 there, and so we have to do the piecewise 2 by 2. If you were trying to do the whole thing, you'd need 4. If entire function, you would need 4. But this part is just the point -2, -3, and this one is just the 0.22, and so it doesn't really appear to be worth it. So to graph that in the calculator, we would go to a piecewise function. So between the 9 and the book, there's this, and we want the 2 by 2 piecewise. So the 2 by 2 piecewise is right there, and we put x cubed plus 8 that's our numerator, divide by x squared minus 4, and I want that when x is not equal to 2. Now I also want that when x is not equal to -2. And I tried earlier, I can't just put a comma there. Maybe I could say the word and. That'd probably be the best. If not, then just retype it. Okay, so we either need 2 spots for that, or use the word and. Just to finish that up real quick, what if I just started over real quick? And said three by 3 piecewise. X cubed plus 8 over x squared minus 4. And I'm going to say x not equal to 2 and x not equal to -2. Need to close some parentheses there. Here we have -3 when x is 2, -2, and here we want 2 when x equal to. Okay, so if you use your keyword and, which I just remembered, then you wouldn't have to have the same function twice. Okay, now my first step on this, go ahead and do your zoom fit menu 4A, and it's going to look like that. So it looks like it's defined except for at the one spot x equal 2. So from the graph, after doing zoom fit, looks like you have a vertical asymptote at x equal 2. Well, what happened at -2? Here we have a -3, and so to find out, we'd actually have to do a little extra math, and I would actually start with factoring. If it's x cubed plus 8, looks like we could factor out an x plus 2. This is just my personal preference. You could probably do this question quicker than me, but I'm just trying to explain this so you understand it. So you need your 0 terms, and the reason why I'm trying to is because I know the cube root of 8 is 2, and also this is the difference of 2 squares, and so we'd be able to cancel. So then we'd have x squared on top, which would give you 2x squared here. We're subtracting, so this is -2x squared plus 0x, and then a -2x here. So this is -2x squared minus 4x. And again, subtracting, so this turns into positive 4x plus 8. So we can say plus 4 here. So there's your 4x plus 8. So factoring x plus 2 gave us this. So what that means is we would have x plus 2 times x squared minus 2x plus 4. And then the difference of two squares would be your x plus 2, x minus 2, so that these now cancel. And so here we want to try x equal negative 2 and see what happens. Because see, the whole point of me doing this is if I go to the table at negative 2, it shows me negative 3, but I want to verify that to know if it's really continuous. So I would say negative 2 squared minus 2 times negative 2 plus 4 over negative 2 minus 2. This is 4 plus 4 plus 4 over negative 4. 12 over negative 4 is negative 3. And so, yes, negative 2, negative 3 does make it continuous. Does make it continuous. Okay, so that's why there's not a part for two answers. There's just one answer, and it's at x equal 2. So again, I know you could probably do that answer much quicker, but this is just showing you that negative 3 would have been the right spot to fill in if you had to end up building your function. Okay, so then the next one, factoring out a 6 would be probably the best method, because if I see a 6x squared and a 6x, we're probably going to be able to cancel those. So when we go to our calculate screen, negative 294 divided by 6 is negative 49. Now that's a good sign also. We can already cancel our 6's, but the square root of 49 is 7, and so this would be x minus 7, x plus 7, and those would cancel. And so to define g of 7, we would just say 7 plus 7 and get 14. So that would be my approach for that. Because if you just put 7 in here, it's going to be a 0 divided by 0. So that's why you have to take a method like this for that one. Now the next one says define f of 6 in a way that extends for it to be continuous. So I know this says 6 squared is 36. So I know that we could probably factor, but now that I think of it, a really quick way for this one would be try 5.999. This would be a quick method. Try 5.999 and see what happens. So we would be doing 5.999 cubed minus 216 over 5.999 squared minus 36. And so 5.999 cubed minus 216. Now I'm going to close my parentheses to make it wrap around, and then divide by parentheses 5.999 squared minus 36. This gives me 8.99 something, and so then approximate that to 9, and that would be your answer. Okay, for the next one, it says this is your graph. Evaluate the limits a through I. So the limit as x approaches 5, if x is 5, that'd be right there. The y value is -4. And then -2 from the right. -2 from the right is going to be down here, which is -3. And from the left is +5. So remember, these are about y values. So basically 5, -4, -2, -3 from the right, and -2, 5 from the left. Okay, the next one says x approaches -2, and not just from the left and right. And so if you have a jump like this, and if it's a different number, then it does not exist, since the left is not equal to the right. Now at +3, we get down here and up there, and so at +3 from the right, you get this number, -4, so that's from the right. And from the left, it's up, and so that just means infinity. So that's up from the left of 3. Okay, and then since these are different, then again you have it does not exist. Then for this one you have x approaches infinity, which means from the right. From the right, the horizontal asymptote is -2. So you put a -2 here. From the left, the horizontal asymptote is, let's look at the graph, that's a -1. Oh, it's a +1. My bad. Okay. So that's a +1 for horizontal asymptote. Okay, for our next one, we have our function, and it says as x approaches positive infinity and negative infinity. In this one, what we do is for x approaching positive infinity, we just plug in infinity there, and we'd have -4 plus 6 over infinity over 3 minus 2 times infinity squared. So what this is -4 plus 0 over 3 minus 0, so that's just -4/3. Now for x approaching negative infinity, this would be -4 plus 6 over negative infinity over 3 minus 2 over negative infinity squared. So to simplify this, this would be -4 minus 6 over infinity over 3 minus 2 over infinity squared. The negative infinity squared is the same as positive infinity squared because of the parentheses. And so this would actually be -4 minus 0 over 3 minus 0. And so you really do get the same number for both. So that's how you work that one. The next one says find the limit of the rational function from the positive and the negative infinity. The easiest way to work this is to find your horizontal asymptote from your ratio. And if you have 9 over x to the 5th over x to the 5th, you get 9. And you can also verify with a graph. But both of these are going to be 9. So if we have 9x up arrow 5 plus 6 over x up arrow 5 minus x cubed plus x plus 8. It just looks like a curvy function, kind of like an x cubed function, but if I do my zoom fit, you actually see you're going to have asymptote. And if we look at our table, these numbers are close to 9. It's 8.65 basically, and 9.66, and then going down. So these are 9 from both the left and right. Again, if you wanted to, go to your table settings and change independent to ask. And for the one with positive infinity, you just put a bunch of 9s. I'm not even going to count. And we get 9. And for negative infinity, I'm going to put negative and a whole bunch of 9s. And I get 9. So, there's a couple of methods. Either use the horizontal asymptote or use table settings, independent to ask, and then you want x as a bunch of 9s, and then you got 9, and then negative and a bunch of 9s, and again you got the same number. So it's really not bad. Okay, on the next one, find the following limit, and it's from the left, because it's x approaches negative infinity. So again, on this one, graph it if you want to, and change independent to ask, like I did above. So basically, one minus x up arrow 3 divided by x squared plus 8x. Now all of that up arrow 5. So there's your graph. If we go to our table, Control T, and then make this independent to ask, then for x approaches negative infinity, then we would want to use like negative and a bunch of 9s. And so I get 1. But that's misleading. So why it's misleading is if you actually go to it, it has 1, and then over here it says e to the 35. Okay, so be very careful if it has that, because in my case, e to the 35th means you should interpret that as infinity. So it's like negative infinity comma infinity. So it's not just 1. Again, there's the e to capital E to the positive 35. So that means infinity. Okay, on our next one, we have negative 2 over x squared minus 16. And you're going to 4 from the right, then 4 from the left, then negative 4 from the right, and negative 4 from the left. So basically just want to graph this. negative 2 over parentheses x squared minus 16. And so there's your graph. And for positive 4 from the right, it's down. And so that'd be negative infinity. Positive 4 from the left is up. So that's positive infinity. Negative 4 from the right is up. So that's positive infinity. And negative 4 from the left is down. So that's negative infinity. Okay, then on this one, just graph it also, but use x, not t. And so for this one, 8 plus 5 over x up arrow 1/13. What we want is 0 from the right and 0 from the left. So this is the right, this is the left. Now you probably want to do zoom fit. Which again is menu 4A. The reason is because all I can see is something from the left. I don't see anything from the right. But when I do zoom fit, I can now see that from the right it's going to be up. So that's infinity. And from the left it's going to be down when it gets close to 0. So that's negative infinity. Okay. Then for this one, find the domain and range of the function. So this is one where we would have a vertical asymptote at x equal 1 from setting your x to the 5th minus 1 equal to 0. And you would also have a horizontal asymptote at y equal 1 from saying x to the 5th over x to the 5th. And we can graph that. X to the 5th over parentheses x to the 5th minus 1. Again, I need to reset my zoom fit. And here it's down, here it's up. But as far as the domain, it's defined everywhere except for where x is 1. So if we say x not 1 in interval notation, that would be negative infinity 1 union 1 infinity. Don't use brackets. And then on the range, we have a horizontal asymptote at y equal positive 1 also. So this would be negative infinity 1 union 1 infinity. It's not always going to be the same thing, but in my case it was because our vertical asymptote and horizontal asymptote were the same. Okay, then our next one is number 14. For this one, you pick your graph. This example shows you 0, 2, and it's not showing up there. It is showing up there. It's not showing up there. It is showing up here. And so then, is the y value 2 at both the right and left? Okay, this one does not look like that. And then what about 0 from the right? Is it 4? 0 from the right is 4. 0 from the right is 3. Okay, so clearly we know it's going to be B. I always like to double check. And also from the left, it was 0. This one's not. Okay, then for this problem, what I like to do is I choose the graph first and then the equation, because I'm a visual person. If you'd like to do it the other way, you can, but is my y value equal to 1 on the far left and the far right? No. No. Yeah. Yes. Yes. No. And yes. Okay. So that's for the first part. Now, at 2 from the left, it's up, and 2 from the right, it's up. Because both of these are positive infinity. So it can't be this one, and this is mixed also. And this is where both were down. This is where both are up, and then this is where it's mixed. And so now this would be your correct answer, F. So what that function is, you would have a vertical asymptote at x equal 2, and you'd have a horizontal asymptote at y equal 1. So that would look like 1 over x minus 2 squared plus 1. And so that would be the D graph, or D function. Okay, and then for this one, they suggest using the conjugate, which would be plus or minus with square roots, but it's really not necessary. If you just plug in infinity, square root of infinity plus 64 minus square root of infinity plus 36. This would just be square root of infinity, which is still infinity, minus square root of infinity. Infinity minus infinity is 0. And so that would be your answer. Okay, so we did get through with all of this in one class period. Let me know if you have any questions.